Welcome back, everybody, to the Deep Dive.
hmm
Today, we're going to be diving into a press release from the Tokyo University of Science,
Okay.
dated March 4th, 2025.
Okay.
And it has got the clean energy world buzzing
Interesting.
with talk of a breakthrough in affordable hydrogen production using a novel catalyst.
Yeah.
So we're going to be looking at that today and what that could potentially mean.
This is exciting. This is a really interesting development.
Yeah. So let's just jump right in. And what's really got me excited about this press release is this new palladium-based nanosheet catalyst,
Okay.
PDI they're calling it, that could potentially rival the efficiency of platinum,
Right.
but at a much lower cost.
Yeah, that's what's really interesting here is that they're highlighting this palladium-based catalyst as a potential, rival to platinum,
Right.
but at a fraction of the cost.
Yeah.
So that's huge.
It's huge. And I think we all know that hydrogen energy has huge potential for a
Yes.
cleaner future. But that high cost of production
Yes.
has been a major roadblock.
Absolutely. And a large part of that cost is due to the reliance on those expensive platinum catalysts.
Yeah.
So if this new catalyst can really deliver on its promise, it could be a game changer.
Yeah, absolutely. A game changer. So I think, to really understand the significance of this development,
Sure.
it's helpful to first grasp the basics of how hydrogen production works and the role of catalysts.
Yeah, for sure.
So you want to walk us through that a little bit?
Yeah, absolutely. So the most common method for hydrogen production is electrolysis.
Okay.
And that's where you pass an electric current through water to split it into its components,
Yeah.
hydrogen and oxygen.
Right.
But this reaction, it needs a little help to speed things up. And
Yeah.
that's where catalysts come in.
Right.
They make it practical to produce hydrogen on a large scale.
So that's where the platinum comes in.
Exactly.
But platinum is expensive,
It is.
and it's not exactly abundant.
Right. It's a precious metal, so it's definitely a limited resource. And platinum has been the go-to catalyst for what's called the hydrogen evolution reaction, or HARR.
Okay.
And that's essentially the reaction that helps those hydrogen atoms combine into usable hydrogen gas.
Got it.
So finding a more cost-effective alternative to platinum
Right.
without sacrificing efficiency
Yeah.
has been a major goal in the field.
So enter palladium nanosheets,
Exactly.
PDI.
That's right.
And from what I've read,
Yeah.
these researchers at Tokyo University of Science, they seem pretty confident about its potential.
Yeah, they do. And their confidence seems to be backed by some pretty compelling findings.
Okay.
The press release details how they use two different methods to create these palladium nanosheets.
Okay.
One is called gas-liquid interfacial synthesis,
Yeah.
and the other is electrochemical oxidation.
Okay.
And they're focusing on this electrochemically oxidized PDI. They're referring to it as EPDI.
Got it.
And that's the one that's showing some really remarkable results in their tests.
Okay, so give us the details. What kind of results are we talking about?
Okay, so they focused on two key metrics.
Okay.
One is overpotential and the other is exchange current density.
Okay.
Now, overpotential is essentially the extra voltage you need to apply
Right.
to get the reaction going efficiently.
Got it.
So lower is better in this case.
Okay.
And platinum sits at around 35 millivolts.
Okay.
So their activated EPDI, you ready for this?
Yeah.
It showed an overpotential of just 34 millivolts.
Wow, that's practically neck and neck with platinum.
Almost identical.
Yeah, so it's using almost the same amount of energy
Right.
to produce hydrogen.
Exactly.
That's incredible.
It's very impressive.
That's very impressive.
And then there's the exchange current density.
Okay.
And that measures how quickly the catalyst facilitates the reaction.
Mm-hmm.
So essentially the rate of hydrogen production. And guess
Right.
what?
What?
EPDI's exchange current density
Yeah.
was also very close to that of platinum.
Wow. Okay.
So meaning it can produce hydrogen at a similar rate.
All right. I'm intrigued.
Yeah.
This is exciting stuff.
Eh.
But we all know
We're-
that a catalyst's long-term stability is just as crucial as its initial performance.
Oh, absolutely. Yeah.
Did the press release mention anything about PDI's durability?
They did.
Okay.
And this is where it gets even more interesting.
Okay.
The researchers, they tested these PDI nanosheets in acidic conditions.
Right.
Which is meant to simulate the kind of harsh environment of real-world hydrogen production.
Right.
And they found that the nanosheets remained stable
Wow.
for an impressive 12 hours.
Okay.
So now, while this is just an initial test,
Yeah.
it really does suggest that PDI could potentially handle the demands of continuous hydrogen production.
All right. I'm officially excited. If this technology lives up to this initial promise, we could be looking at a major shift in the clean energy landscape. But I think before we get too far ahead of ourselves, let's talk about the real-world implications. Like, What are some of the potential applications of this PDI technology beyond the lab?
Well, the press release highlights, a wide range of possibilities,
Right.
starting with the most obvious, industrial hydrogen production.
Right.
So imagine factories and power plants producing hydrogen fuel, at a fraction of the current cost.
Okay.
But it goes beyond that.
Yeah.
They're also talking about hydrogen fuel cells for vehicles,
Right?
which could potentially lead to zero-emission cars and trucks,
Yeah.
and even large-scale energy storage systems,
Right.
which could revolutionize how we manage and distribute renewable energy.
Yeah, it's like a domino effect.
Yeah.
Like a more affordable catalyst
Yeah,
could just trigger this wave of innovation
exactly.
across multiple sectors,
Yeah.
from transportation to energy grids.
That's right.
It's exciting to think about the possibilities.
It is.
But of course, there are always challenges when it comes to scaling up a new technology
For sure.
and bringing it to market.
Absolutely.
Yeah.
The researchers at Tokyo University of Science, they acknowledge that they're still in the early stages. One of the biggest hurdles is going to be scaling up production.
Right.
Creating a small batch of nanosheets in a lab is one thing,
Yeah.
but, manufacturing them on a massive scale while maintaining quality and consistency, that's
Right.
a whole other challenge.
It's the classic case of, can it go from the lab bench to the factory floor?
Exactly.
So assuming they can crack that nut, what other challenges might they face?
Well, I think integration is a big one.
Okay.
Our current energy infrastructure is largely built around fossil fuels.
Right.
So transitioning to a hydrogen-based system would require significant investment and adaptation.
Yeah.
We're talking about, new pipelines,
Right.
storage facilities, refueling stations, and potentially even modifications to our power grids.
So it's not just about the technology itself,
Yeah.
but how it fits into
Yeah.
the larger energy ecosystem.
It's the whole picture.
Yeah. It sounds like a monumental task.
It is, but the potential rewards are significant.
Right.
And, the press release specifically highlights how PDII aligns with the UN's Sustainable Development Goals,
Okay.
particularly SDG 7,
Uh-huh.
which focuses on affordable and clean energy,
Right.
and SDG 9 promoting industry innovation and infrastructure.
So it sounds like they're hitting on all the key points: cost effectiveness, efficiency, sustainability.
Absolutely.
They even touch on how this could reduce our reliance on platinum,
Yes,
which would have, obvious positive environmental impacts as well.
for sure.
But I kind of want to dive deeper into the potential impact.
Okay.
The press release mentioned something about PDI
Yeah.
potentially revolutionizing the automobile and electrode manufacturing industries.
Yeah.
Could you elaborate on that a little bit?
Certainly. Let's start with automobiles.
Okay.
As I mentioned earlier, one of the most promising applications of PDI is in hydrogen fuel cells, which could power vehicles with zero tailpipe emissions. So replacing gasoline with hydrogen would significantly reduce air pollution in our cities and decrease our dependence on those fossil fuels.
Okay, so cleaner cars, less pollution. That's a future I think we all want to see.
Absolutely.
But what about electrode manufacturing?
Okay.
How does this new catalyst play into that?
Well, remember that at its heart, PDDI is a highly efficient electrocatalyst, and electrodes are essential components in a vast array of electrochemical processes, from batteries to sensors to water treatment systems.
Okay.
Currently, many of these industries rely on expensive platinum-based electrodes.
So PDI could provide a more affordable
Exactly.
and readily available alternative,
That's the idea.
leading to cost reductions and maybe even performance improvements across multiple industries.
Right. It's about opening up possibilities.
Right.
A less expensive, more efficient catalyst could spark a wave of innovation in fields like energy storage
Right.
and chemical production.
So we've covered a lot of ground here. The science behind PDI, its potential applications, the challenges of scaling and integration,
yeah,
and the broader societal and environmental implications.
for sure.
It's a lot to take in,
It is.
but it paints a very compelling picture
Yeah.
of what the future could hold.
Yeah.
But before we wrap up this deep dive,
Okay.
I'd like to get your personal perspective on this discovery. Like, what excites you most about the potential of palladium nanosheets?
I think what really excites me is the potential for this technology to finally bring the hydrogen economy,
Uh,
from the realm of theory into reality.
yeah.
We've recognized hydrogen's potential as this clean and abundant and versatile energy carrier for decades,
Right.
but cost has always been the Achilles heel.
Hmm.
So if PDI lives up to its promise, it could be the key to unlocking that potential and accelerating our transition to a truly sustainable energy future.
I think that's the takeaway that's resonated with me the most, too, is the possibility of making that transition not just possible, but practical.
Right.
But you've pointed out, even with a breakthrough like this,
Yeah.
there are significant challenges ahead.
So let's shift gears a bit. I'd like to tap into your expertise to kind of paint a clearer picture for our listeners.
Sure.
Let's say this technology takes off
Okay.
and we do see the emergence of a hydrogen society. What does that world look like? How would their everyday life be different?
That's a great question. Imagine a world where your car runs on hydrogen,
Okay.
emitting nothing but water vapor.
Wow.
Picture cities with cleaner air, because buses and delivery trucks are all powered by fuel cells.
Okay.
Think about homes heated and powered by hydrogen,
Right.
perhaps even generated locally through small-scale renewable energy systems.
It's a pretty amazing vision, and one that I think resonates with a lot of people's hopes for a cleaner, more sustainable future.
Yeah.
But these kinds of societal shifts don't happen overnight.
No, they don't.
So what are some of the hurdles that we need to overcome to actually make that transition a reality?
Well, I think infrastructure is a big one.
As we've discussed, we need to build out a whole new system for producing, storing, and distributing hydrogen.
Right.
So think hydrogen pipelines, refueling stations, and even potentially adapting our existing natural gas infrastructure for hydrogen use.
Right, because we're not just swapping out one type of fuel at the pump. We're talking about a fundamental rethinking of how energy moves through our society.
Exactly. And then there's a question of safety.
Okay.
Hydrogen is flammable.
Right.
So we need to develop, robust safety protocols and technologies to ensure that it can be handled and stored safely, both on a large scale and in individual homes.
That's a critical point. New technology often comes with anxieties and, ensuring public safety is paramount.
Absolutely.
But I'm also thinking about, the potential economic and geopolitical implications of a shift to hydrogen.
Right.
Could this be a path towards greater energy independence for many countries?
It certainly has a potential. One of the key advantages of hydrogen is that it can be produced from a variety of sources, including renewable energy like solar and wind power.
Right.
This means that countries could potentially generate their own hydrogen fuel,
Yeah.
reducing their reliance on imported fossil fuels
Right.
and creating new economic opportunities.
That's a truly compelling aspect. So we're talking about cleaner air, a more sustainable energy system, and possibly even greater energy security.
Right.
It's hard not to get excited about the possibilities, even with the challenges ahead.
Yeah, and I think it's important to emphasize that a transition like this won't happen solely because of a single technological breakthrough.
Right.
It's going to require a concerted effort from governments, industries, researchers, and individuals.
Of course.
We need continued investment in research and development, smart policies that incentivize the adoption of hydrogen technologies in public education to build understanding and support.
Well said. This deep dive has certainly given us a lot to think about. A potential breakthrough technology, the promise of a cleaner, more sustainable energy future, and the significant challenges we need to overcome to get there. But one thing is clear. The conversation about hydrogen is gaining momentum, and discoveries like this palladium nanosheet catalyst are pushing the boundaries of what's possible.
Absolutely. And for our listeners, I think the message is this: stay informed, stay engaged, and be part of the conversation about shaping our energy future.
Great advice. And on that note, I think it's time for us to surface from this deep dive into the world of palladium nanosheets. Thanks for joining us, and until next time, keep diving deep.